Hi, this is Alan Ivora with Affinity Energy. Today we're going to be talking about power quality monitoring and metering, and we're going to show you how easy it is to analyze, understand, and take action, or at least have the information required to take action on power quality events that may be occurring within your facility. Our focus today is going to be on the ION 7650. And what I would like to go over is the ability to detect sags, swells, and transients, and the difference between how power quality events used to be analyzed versus how easy they are to analyze today. So what we're going to do is we're going to use this meter test kit along with some pre-installed power monitoring expert software, which is also provided to us courtesy of Schneider Electric. And we're going to demonstrate how easy it is for a facility owner or a plant manager to understand what's going on within their facility without having to be an electrical engineer. On my computer here, I have Power Monitoring Expert installed. Power Monitoring Expert is an electrical power management and control system software that is developed by Schneider Electric, and it is a software that is used to communicate with various meters and relays and other mitigation equipment in order to manage and understand your electrical distribution and your power reliability equipment. Specifically, what I have here is I have the web version of Power Monitoring Expert, which is showing me some information from the electric meters that are currently in this test kit. And within our building, you'll see that we have several meters, and they're currently shown here within the network diagram. And you can see that we have the demo 7650, the demo PM8000, and the demo PM5500. I'm going to focus on the demo 7650, which again, if I select it, this is an out-of-the-box template that comes with the software. Again, it takes less than 5 minutes to connect the meter to the software, especially if you're using Ethernet, and be able to read the power parameters from your meter, your standard voltages, your currents, your real, reactive, and apparent powers, along with your energy consumption. So this is, again, a standard out-of-the-box template that comes with the software, requires no custom configuration, but allows you to interact with your meter. It automatically records the data from the meter so it can be trended and reported on. A very straightforward implementation. The 7650 is really considered a high-end power quality device. We typically recommend the 7650 on the service entrance, or some people will call it the incomers to your facility. And that's because this is a very powerful meter. It has the ability to capture transients. It has the ability to capture sag swells. It analyzes flicker. It also has harmonic spectrum capability along with built-in I/O. So for example, if you want to monitor some transformer alarms, if you want to monitor some high voltage switch positions, if you want to monitor maybe pulse counters from your utility meter so that you can separately shadow bill your utility. This meter can really do it all. You know, not so long ago when you used to work with Power Monitoring Expert or ION Enterprise, when you interacted with power quality, you primarily interacted with this specific part of the meter template. It has the ability for you to set up some of your sag and swell limits, define your nominal voltages, and enable and disable the recording of sag, swells, waveforms, harmonics, and transient detection. And then it also shows you some information on the disturbances that have been detected within this device. Let's say that you had a sag and swell and you wanted to look at the particulars of what happened during that sag and swell. You know, before there was a much easier to use software tools, you would typically click on the historical viewer here, and that would provide you with a sequence of events, which would be timestamp events here that you would see each specific incident of either a transient or a sag or swell. This particular meter, along with the PM8000, have a very beneficial function that's included within them, disturbance direction detection. And that's the ability for the meter to tell you as the user whether that disturbance came from upstream or downstream, external versus internal. It will allow you to determine where to look or where to start root causing your problem. So for example, if you put this meter on the service entry point for your building and you disturb a transient and it occurs upstream, then obviously you're going to have probably a conversation with your electric utility. The way we used to look at these things in the old methodology is we would select a particular disturbance and we would select the waveforms. In this case, I'm going to look at the voltage waveforms, and then we would show a graph. You can see that it captures so many waveforms prior to the event, and then you have the event itself, which again looks like it persisted for, again, fraction of a second, and then the disturbance disappears, and then we have the waveform continuing again. To someone who's a novice or who's not an electrical engineer, this really doesn't provide a whole lot of context. It doesn't allow you to determine really what do I do about this waveform? Did it have an impact on my facility? You know, is it of a magnitude that it may have damaged equipment? It doesn't really guide me in how to go about analyzing or figuring out what I need to do to perhaps prevent this from occurring in the future. So that's what I'm going to go over today, are some of the tools that are allowing us to go over how we might better use software in order to understand what's happening within our facility. Now, another important tool that was used in the past in order to analyze your disturbances was something that's called the SABIMA plot, or the ITIC curve. And I'm going to show you that here just so that you can get an idea of how the new software makes analyzing disturbances easier. The SABIMA plot was an envelope that would show you as a user whether or not the duration and magnitude of that disturbance may have caused damage to sensitive equipment within the plant. This was a duration of about 0.02 seconds. So again, it's about a little bit more than a cycle, because a cycle is about 0.0167 seconds. And you can see that its magnitude was up there somewhere around 280, 300. So again, if we're at a nominal voltage of 120, it's more than twice the magnitude for a duration of that's about a little bit more than a cycle. So based on this curve, we could have made the assumption that that particular event could have caused damage to sensitive equipment, electronic equipment within our facility. So what I'm going to show you now, though, is I'm going to show you a couple of the tools that are standard out-of-the-box tools that are provided with Power Monitoring Expert that give you, the owner, a little bit better idea of what's happening within your facility. So I've got a dashboard here that's kind of set up with a couple of power quality details. And here's, I'm going to go through a couple of these, they're called gadgets, and which are essentially different ways to view your information within Power Monitoring Expert. This particular one here is what's called a power quality events breakdown. The content or the amount of events here come from both information that has been gathered from our test kit, as well as information that has been gathered from our meter on our specific facility. Here you can select a particular time frame. I could look at this week, for example. 50% of our events have been swells. We've had one transient, or 10%. We've had 2 interruptions of service, and we've had 2 sags. So again, a nice high-level picture of the types of events that are occurring within our facility. Now, the next chart here is a power quality events impact. This is actually just showing this month. It's saying that we had 11 events. 8 of these events likely had impact within our facility. It's kind of raising the flag to me as a facility manager, facility owner, to say, you know what, we've got some things that require some investigation within our facility. And so again, I don't have to be an expert, and I don't have to go and plot the Sabima plot and see whether or not the disruption lies outside of the envelope. I've got a simple methodology here to certainly look at whether I've had impactful events or no impact events. This third gadget, which again is related to power quality, is an impact, no impact. The one to the left here that's shown in yellow are external events that have been detected. The one in the middle here are internal events that have been detected. And then the one to the right here are events that have been detected, but the confidence level in determining the direction is low, and therefore it's undetermined whether the event occurred external or internal. It will show you, for this particular case, we had 3 events that occurred and were originated external to our facility, and of those 3 events, 2 of them had potential impact in terms of damaging sensitive electronic equipment within our facility. You can see that we had a total of 5 disturbances that occurred internal, so they originated within our facility. Maybe we brought on a bunch of motors and we didn't sequence them properly. Maybe we had a welder machine, and that may have caused perhaps some spikes or surges within our electrical distribution. Of the 5 events that we experienced internal to our facility, all of them likely had an impact. And then here we had 2 events that were undetermined in terms of where they originated, with one event having potentially had an impact and one event having no impact. So again, these charts here are standard charts that are available within Power Monitoring Expert, and they give us a high level kind of view of some of the details that are happening within our electrical distribution system, assuming that we've got the power quality monitors that support the direction detection and also capturing sag swells, transients, and other power quality interruptions. So you might say, well, what if I want to look at, some KPIs related to my power quality? Well, there's a couple, again, built-in tools, and I'm going to go over 2 of them here. One of them is called the Power Quality Rating. In this particular case, all it is an assessment that's done based on the time frame that you want to look at. In this case, I'm looking at this month. For my facility right now, on an overall scale of 0 to 100, I'm basically about a C. So I'm average, because and it's saying the main contributors to the reason why my power quality rating is what it is because I have had interruptions, I have had transients, and I have had swells. So again, depending on when you look at the data, so for example, I just picked today. Today we've not had any interruptions, no sag swells, disruptions, so you can see that our rating is 100%. We're going to generate a sag swell event in a few minutes, and you'll see how the system detects that, and then you'll be able to see how that rating changes after the experience of a voltage disruption within the facility. So the other chart that I want to show you is, again, it's a power quality rating trend. So it's similar to the rating that we just looked at, but allows you to show the trend over time. So in this particular case, you can see that we're showing the trend for this month. We had an A every day with the exception of yesterday. And we had the C rating, which has really influenced our overall monthly rating. And that was primarily because yesterday, in preparation, I was generating some sag swell events on our test meter here so that we could have something to look at that would show something other than a perfect rating for the month. Now, if I were to go back and look at this for, say, the last 30 days, I think you'll see we actually have had some events within our facility, and here you can see the trends going all the way back to October 11. Our rating again, was only a B on these particular days. To demonstrate how the system works in terms of detecting and then analyzing these particular events, we're going to generate a sag swell event. We're going to look at a couple things. We're going to look at the device, and we're going to see how the device detects the disturbance. And then we're going to see how the particular gadgets or the charts get updated to reflect the disturbance that was detected. So what I'm going to do, I have the system set up here, and I've got the dial set up actually to provide a pretty long duration sag or swell, and I've also got it set to maximum magnitude. And I'm going to go ahead and I'm going to use this button here, and I'm going to generate a sag event. We can see that right now our disturbance counts are that we have 26 sags and swells and 358 transients, and I'm going to generate a sag. What has happened now is our sag swell count has actually incremented. So it actually generated 2 events. So it went from 26 to 28. So you can see here each of them is displayed. So one is at 11:04 and 24 seconds, and the other one is 11:04 and 27 seconds. It looks like both of these occurred upstream. One of them was with higher confidence, the other one was with lower confidence. Again, if you wanted to plot these, you could pick them, and we can look at the particular waveforms. So let's just go ahead and pick them. We'll show the graph. So you can see here where all of a sudden, actually there was significant, impact in terms of the voltage. So for about 0.3 of a second is how long that particular event lasted. So let's look at our dashboard here. So a couple things right off the bat you're going to notice is our rating in terms of our power quality rating for our facility is no longer 100%. It's dropped to 95%, and it does list that there's some main contributors today. It had some interruptions. So perhaps one of the things we can do here is we'll generate another event to see it drop below the 95 into the B range. So what I'm going to do is I'm going to go ahead and generate a swell event. So after generating our swell, we see that the disturbance count incremented from 28 to 29. We can see that the disturbance, the last disturbance, is now 11:08 a.m. So again, just recently. And if we go to the sag swell and we look at our event chart, we can see that again at 11:08 and 3 seconds, that we have an upstream medium confidence event that was detected. So let's just go ahead and if we plot that graph, so here you can see again your normal waveform, and then all of a sudden you can see that the RMS voltage is going to increase. But let's go back now to our dashboard. Our PQ rating has now dropped from 95 to 90, so we're now in the B range. And our contributors are, we had an interruption and we had a swell. In addition to that, when we go over and we look at our trend now, you can see that for today, our trend has dropped to a B rating. These details here will have been updated to reflect those particular power quality events. So for example, if I were looking at the events breakdown and I just wanted to look at today, well, I have two events. I had an interruption. So an interruption is really a loss of power. So we had one interruption and then we had a swell. Similarly, if we were to look at the impacts, and I just wanted to look at the 2 that I did today, we're going to see I had 2 events, and most likely there was impact within our facility as a result of those 2 events. And similarly, I'm going to look at the event location just for today. And you're going to see that we've had 2 events that we believe originated external to our facility, and both of those events likely had an impact. So again, these are simple tools that can be used within your power monitoring expert system, in order to analyze and understand what's happening from a power quality perspective. No longer do you need to be an electrical engineer or even well versed in electrical distribution systems to know that action needs to be taken with respect to what you're experiencing within your facility. I do want to show you one more tool that we'll cover in more detail in the future. So I'm going to give you a little bit of a preview. And this tool is referred to as the Power Quality Advisor. Now this particular tool, it's a very affordable add-on module. And this is a view of it. It can be displayed within a gadget, so on your dashboard. And it's a simple way to categorize your different types of power quality events. So you have interruptions, you have transients, overvoltages, undervoltages, sags, swells, unbalance, harmonics, etc. So let's say that in terms of looking at interruptions, you've installed some UPSs to prevent interruptions from occurring. Then this particular add-on module will actually show you how well that mitigation equipment, whether it be a UPS or maybe you have low power factor and you've installed some capacitor banks, it'll show you how well that equipment is operating, and it'll relate that to the events that are occurring within your system. There's not a great mystery around power quality. You don't have to be an expert in order to be able to analyze and hopefully root cause and identify some actionable items. So thank you for joining me today on today's video covering power quality monitoring and ways in which to analyze and interpret the events that are recorded by your power quality meters and monitors. Look forward to our future video discussing the add-on module, the Power Quality Advisor, as well as some videos covering mitigation equipment to help remedy and reduce the amount of events that occur within your facility. We'll look forward to catching up with you soon. Take care.